about revision. So kind of like how yesterday's lesson was just about revision. So that's why I'm not going to dwell on this too much. So let's have a look. What is on the Unit 1 exam? As you can see for the Unit 1 exam, one of these is a lot more dense than the other. And this is one of the reasons why I always said that financial maths is one of the hardest topics to do. But out of all of these, they will all be worth about a quarter of the exam. So you shouldn't be spending more time on finance. You should spend some time you should try and spend a little bit of time on each of them. Obviously, you should focus on the areas that you struggle with. So focus on your struggling areas, right? So if you struggle with financial maths, spend some time focusing on financial maths, but don't neglect the others. What that means is don't spend all your time doing financial maths. Because if you spend all your time doing financial maths, and then I give you a logarithmic question, right? If I give you questions about logarithms, you're like, oh, I have no idea how to do that. Then it doesn't matter how much time you spend doing financial maths, you're going to tank on that question. So you should try and spread your time out evenly. Now, it's a quick point. The next quick point I wanted to make with you guys is that all of these are, these are the 4 topics: arithmetic, financial maths, or financial arithmetic, algebra, and matrices. Now, what I've done is, and I've done this like really quickly, like this is what I was doing, is I just put a bunch of dot points down for each of these for the kind of things that we studied. I started with matrices because we've just done matrices. Then I went back to algebra, and arithmetic was the hardest one because we've been so long since we've done it. Some points that I think would be difficult, that are worth the difficult areas that I think you may struggle with are, of course, logarithms and logarithmic scales. I think that the using scales from the ratios, as I said, a lot of you guys couldn't tell me when we were doing the test that if I had a 1 to 2 20,000 ratio, what is 3 centimeters in, what distance is that? You guys couldn't tell me it was 60,000 centimeters, which is actually the same as saying 6 kilometers. Like, that's what I need you guys to be able to do. In financial maths, probably the biggest areas that you guys struggle with was, of course, the calculating personal loans, credit cards, and I think, where is it? Hire purchase agreements were the ones that you guys stressed out the most about. So there's some that you might want to relook at, reinvestigate. Algebra, it was pretty much just out of 2, which was creating equations from worded problems and simultaneous equations. But both of those are like feed into each other, so they're pretty important. And the last one was the other one as well, by the way, for this one was percentage increase. That's actually not a difficult skill for people to do, but it's one of the skills that I saw people get wrong the most. So just make sure you look at that one. And matrices, of course, the hardest one would probably be finding the inverse. There's some of the things that I think you might want to investigate, you might want to look into, because these are the areas that I've noticed that students struggle with. They struggle with these guys a fair bit. Would you guys agree? Are there any here that I have missed? You guys actually that's the hardest one? Or do you guys agree with mostly with what I've said? Are there any here? Are there any dot points that I've missed completely? Are you guys like, oh my God, so you forgot to write down blank? What do you guys think? I want to get some interaction from you guys. aside from Min doom and gloom, which he says he's about to fail in chat. Give me some interaction. What do you guys think is the hardest thing that's going to be on the test? Is personal loans the same as hire purchase? No, someone said that in chat privately. No, they're not. A personal loan is a little bit different. Personal loan questions are the ones where it's like, you get a deposit and but you borrow some money. How much? It's pretty much personal loans are pretty much just compound interest questions. They're a little bit different. That was actually pretty much everything that was in 4E Part 2. Now 4E Part 2 is pretty small, so I don't expect you guys to know about it. A hire purchase is all about like, if you purchase something and you hire it and you do this many repayments at this time, then how much is it? What's the equivalent rate of interest? Stuff like that. Anyone else? They got a point? What do you guys think is going to be the hardest thing on the exam? What do you think is going to be? What do you guys think I've missed? What are you guys struggling with? Just give me one more point before I can move on.
So can you give us a logarithmic scale like question example?
Sure, I can show you what they look like. Someone said when higher purchase agreement is one of the things I'm majorly struggling with. So I'm not going to say who said this. I just need to relearn some stuff. Yeah, I get that. I think the hire purchase one is a bit difficult because the reason the hire purchase is a bit difficult is because it's just it doesn't really follow any set rules. The questions could ask, how much do you have to pay each month? The question could ask, what is the equivalent rate of interest? There's so many things you could ask, but you've just got to be comfortable with just simple multiplication first time. Logarithms, they're the ones that look like this. So the classic ones I think I was giving students back in the day was if I gave you guys logarithm of 10 base 10 of 1,000, if I gave you base 10 of x equals 3, then you'd have to go 10 to the power of 3 equals x equals 1,000, and that was about as hard as they got. That was the logarithm based question. The logarithmic scale, that was just like looking at a logarithmic scale and being able to figure out what it looks like. That was the last exercise 1F. It had a lot to do with the whole orders of magnitude, and also that was the one where the questions were about like if you have an earthquake which measures 10,000, and then you have 10,000, they have another earthquake that measures 150,000 or something like that. How many orders of magnitude is greater than this? And then like you could actually do the logarithms of those to see what the difference in their logs were. That is definitely one that you might have to actually have a look at. Some other things in chat. Would it be cool if okay, so at this point, yes, so I'm going to be at school, I think, most of next week, pretty much all of next week anyway, so you can come find me at school, but if you don't want to, you can send me an email. Ladies and gents, at this point, what are we at? Okay, let's go look. We're now at 10:05. So you guys have got 30 minutes. Now, some of you guys, let me do this so I can actually talk to you guys. Some of you guys at this point will probably be wanting to head off and do your own revision. That's completely fine. If you guys want to head off and do your own revision, then that's okay. I've got a couple of options for those of you that don't want to do that. For those of you that guys that want to stick around, on this PowerPoint slide, I actually have 3 questions. One from financial arithmetic. I just pulled the credit card question out of nowhere. One for original price, which is about some boots. And then I did one for simultaneous equations. So this is just a simultaneous equation got to do with popcorn and stuff like that, and other things essentially at a cinema. If you guys want, I can go through these. Where is it? Was there anything in chat? No. So pretty much, and looks like a couple of people left, but a lot of people stayed. But you know, no one's really told me what they want to do. So Henry, you win. So you're the first one. So you get. This is logarithmic scales. This is 1n. That's where logarithmic scales showed up. And what we can do is we can look at an easy one and then we'll look at the hardest one. So we'll actually just jump from one to the other. So a logarithmic scale, let's look at this. How do you do that? Let me just, sorry, give me a second. I remember I learned how to do this. I felt so fancy. It's like, look at that. How cool am I? Sorry, completely off topic. Okay, so let's go look at this top one and the second from the top one. So question 1, this is a logarithmic scale. How many times stronger is a magnitude 7 earthquake than a magnitude 5 earthquake? So you've got to know that earthquakes are a logarithmic scale. So that means you can't just go like, oh, 7 divided by 5 and get whatever, that's like 1 point whatever. You can't do that. That's not how it works. What you have to do is you have to go, well, so you could think about this in 2 ways. The easiest way to do it, I'll show you the easiest way and then I'll show you the mathematical ideas behind it. So the easiest way to do it is just to go, well, a magnitude 7 take away a magnitude 5 is going to be 2 orders larger. Now, if it's 2 orders larger, then that means you've got 10 to the power of 2, which is equal to 100 times larger. And that's how you would do this first one.
So where you pull the 10 from?
Because it is earthquakes are measured with a ratio of 10. So a magnitude.
So that's a base knowledge we're supposed to know.
Yeah. Same with decibels as well.
So what equals 10 again, sir? It's earthquakes, right?
Yeah.
So okay, so earthquake is 10, and what's the other one?
Also 10. Well, sort of.
Oh,
a bit different.
yeah.
You'll have to look. I'll have to show you. That's
Okay.
question 6. So we don't have to worry about question 6 yet. So where's the little bit more of the maths of that? So an earthquake of magnitude 5, that's going to be 10 to the power 5. That's going to mean that it's going to be 10,000. Whereas an earthquake of magnitude 7 is going to be 10 to the power of 7, which is going to be oops, hold on. So that's 1, 2, 3, 4. Actually, hold on. There we go. I got that wrong. So now, whereas this one is going to be 10 million. So if you go compare these two, if you multiply this one by 100 and add 2 more zeros to it, then that's how you get it. That's why it's 100 times larger. Now that one's not too bad. But what about when we have numbers where the numbers are not that different? What if you have a magnitude 7.4 compared to a magnitude 7.7? How would they work? So 7.7 minus 7.4 is only going to be 0.3. So what is that? Well, you would do the same thing. You go 10 to the power of 0.3. 10 to the power of 0.3, I'm going to have to get my calculator out, because that's not going to be, is 1.995, or it's just 2. So it's 2 times larger. Now you could actually perform the same thing that we just did here, where you could go 10 to the power of 7.4 and 10 to the power. How then do you get from 10 to the power of 7.4 to 10 to the power of 7.7? But it is easier just doing this. So that's how you would work out these types of scales. Now, the decimal scale, sorry, not the decimal scale, the sound scale is a bit different, 80 decibels. The reason that decibels are a bit different is that if you look at this scale at the top, they give you these results straight up, 7.4. That is already log of x equals 7.4. But when you deal with, when you're looking at sound is difficult because instead they don't just do it, they multiply it by 10. So I'm going to show you the tips and tricks you need in order to deal with sound questions. So let's go have a look at a sound question. So the sound of a vacuum cleaner is 80 decibels and someone's whispering is 20 decibels. How much softer is the sound of someone whispering compared to the vacuum? Now, if you want to look at how much softer, I think it's actually easier to look at how much louder someone speaking is to someone whispering and then just saying, oh, it's this many times softer. But you could do it any way you want. But let's do this. You can't just go, let me show you what you can't do. A lot of people would want to do the same thing we just did. Oh, let's just go 80 minus 20 equals 60, 10 to the power of 60. That's not how you do things. The reason is because we're looking at decimal scales, and decimals are all multiplied by 10. So what you need to do is you need to go 80 divided by 10 minus 20 divided by 10, which is 8 minus 2, which is 6, not 60. If you go 10 to the power of 6, well, that's going to give you 1,000,000. So you can now say it is 1,000,000 times. It's 1,000,000 times softer. Now, if this was instead of 80, if this was 81, you would go 81 divided by 10. You do the same process. Now, I just happen to know that 10 to the power of 6 is 1,000,000. It's got 6 zeros, so that's why I was able to go straight up and just solve it so quickly. We can check the answers. It might not be 1,000,000 times softer. It might be 0.0000001 times softer, but it should be around this value here. Let's go have a quick look at the result, the answers actually. How can we look at the answers? We should go. Oops. Whoa. What have I done here? Give me a second. Sorry, William. William? Why I call you William? Oh God. Henry. God. Okay, give me a sec. I just need to pop open the answers so I can just double check that we got the correct answer, which is about 1,000,000. So there we go. Technology, am I right? Here we go. So here's chapter 5, chapter 1, F, question 1, and yeah, okay. So they said 10 to the negative 6 times softer. And you might say, oh, so we got the answer wrong. Well, not really. We said, you might say, we did get the answer. Well, we did sort of get the answer wrong, but not. But we were almost there. We said that the speaking speaking is 1 million times louder, which is times 10 to the power of 6 louder, which means the other way, if we wanted to find out how much quieter, it's 1 over 10 to the 6 quieter, or 1 10 to the negative 6 quieter. But honestly, to be completely honest with you, if you got a million, don't think, oh my God, I got the answer wrong. You pretty much got the answer right. You've just written it in a different way. And I actually prefer saying, oh, this is this much louder, rather than saying this is this much quieter. And if you actually look at every single other question, it says heavier, louder. And the other two answers we did get was 102 times. So that was good. So it doesn't actually ever say, softer. It's only this last question that's softer. So I'm pretty happy that we got that right. You might think that we did get it right, so therefore failures, but like, hey, million times louder is the same as a million, is the same as saying a million as loud. Tell me the quick whereabouts the question is, and we can work.
Financial section.
Question 8?
Either 6 or 8. Yeah.
6 or 8. Okay. Let's go look at 6. So we've got Kim. What color do we want to use? Yellow? Maybe yellow? No, probably red is safe. Kim is $18,000 to invest in 2 years. She has the following options: a term deposit, okay, so this is more of a calculation one. Whereas I think question 8 is more about the exact question we're sort of looking at. So let's go look at question 8 instead. So question 8 sort of says, calculate the compound interest calculate the compound interest for a calculate the compound interest on a term deposit of $10,000 for the rate of 6% per annum for 3 years when the investors compounded annually, semi-annually, quarterly, monthly, daily. Okay, so let's do this. Okay, so this is going to stretch my old muscles. Luckily, I've got my calculator here now, so I can actually solve some of these problems. So let's start off with the simple interest formula. Simple interest formula is, sorry, not simple interest, compound interest formula equals, A equals P1 plus R over 100 n, all risen to the power of nt. Now, the reason we put this formula up here is because in this question, we have various different forms of n. N is, for those of you guys that don't remember, n is how many compounds per year. Per year. And T is time in years. So that means with just this formula, we can run through all of these calculations. First, what we're going to do is we're going to start this. For n in annually, n is 1. There is only 1 year in a year. There's only going to be 1 compound every year. For semi-annually, what's n going to be for semi-annually? What do you guys think? Or Lena, because you're the one asking the question. What do you think n is for semi-annually? 2. And then for quarterly, what is it?
4.
Yep. Monthly is going to be 12, and daily we're going to do 365. Beautiful. So all we need to do is we need to just do this question. And T, by the way, for all of these is going to be 3 because it's 3 years. We don't have to worry about mucking around with T. Some other teachers use this formula differently and they go, oh, well, we're just going to, we're going to worry about all this together. And I'm like, no. Let's just keep it simple. Let's keep T in years. It can get a bit complicated when you start looking at T and it's not in years, it's in months and you got to convert it back to years. But we're going to focus on it being in years. So, and then we've got P, which is the principal, which is 10,000. So let's calculate these. Let's go. We'll start with blue for annually. Let's do annually. N equals 1. So that means we're going to have A equals 10,000 multiplied by 1 plus the rate, which is 6%, equals 6 over 100 times 1 over to the power of 1 times 3. Now I'm going to put all that into my calculator. I'm not even going to do any more steps. I'm just going to go 10,000 times 1 plus 6 divided by 100. All so risen to the power of 3. That gives me 11, 910. If you guys get something different and I've made a mistake, please let me know. So that's N equals 1. Let's now do the next one. Let's do this one. N equals 2. Guess what? It's the same formula, except instead of over 100, we're going to be over 100 times 2, which is 200. And instead of risen to the power of 3, we're going to raise this to the power of 6, because 2 times 3 is equal to 6. So let's do this. I'm going to take my old formula and I'm just going to change it. I'm going to delete the 3 and put a 6. And then I'm going to delete the 100 and put a 200. Job done. That gives me 11940. So we have, by just doing that extra compound, we managed to get ourselves an additional $30. So that's not bad. And it's not bad, especially if you think about that, you know, it doesn't cost anything extra to do that extra compound. Well, you know, it's just like, oh yeah, whatever. We're still doing the same maths. We're not borrowing more money. We're just, you know, calculating how much we've earned more often. Let's go for brown. We're going for brown. We're going for quarterly. N equals 4. You're beginning to see the process here. A equals 10,000. 1 plus 6 over 100 times 4, all risen to the power of 4 times 3. So that means we're going to be going to the power of 12. So I'm going to take my equation, I'm going to change it. I'm going to change that 100 to a, I'm going to change that 200 to a 400. I'm going to change that 6 into a 12. Gives me 11956. Now we've made some more money, but we haven't made a lot more money by going to quarterly. We've made an additional $16 on what we had half yearly or semi-annually to this. What about monthly? Are we going to see a big jump with monthly? Probably not. As you can tell though, however, I am running out of room because I have not set this out very well. So I'm going to do this next one here a little bit up. So N equals 12. We would substitute that one in. A equals 10,000 times 1 plus 6 over 100 times 12. All risen to the power of 12 times 3. So that's going to give us, I'm going to do this in my calculator again. I'm going to replace the 400 with 1200, and I'm going to replace the 6 with 12 times 3 is 36. Some good points here, by the way. You don't actually need to calculate these in your head. what I mean by that is if you don't know that 12 times 3 is 36, which you should know because you are in general maths, you can still put brackets around this and just raise it to the power of 12 times 3. That's completely fine. For example, I'm not going to know what 365 times 3 is. So I'm just going to put those in brackets when I do this last one. Last one is daily n equals 365. Okay, 365, A equals 10,000. 1 plus 6 over 100 times 365, all risen to the power of 365 times 3. So this is one of those ones that I'm going to put in I'm going to get the calculator to figure it out for me. I'm going to say, okay, so we've got 10,000 times 1 plus 6 over 3,600, all to risen to the power of 365 times 3. 11971.9911. Actually, it's pretty much going to become 11972.00. Cool. So, which investment is best? Obviously, it could have told you this from the start without even doing it, but now that we've done it, we can see here that the best investment is going to be daily, because daily gets you the greatest amount. It was always going to be daily because the answer is more compounds equals more interest. That's all you have to know. If you compound, you can see that every time we compound more, we get a jump. We get a jump of $30 here. We get a jump of $16 here. We get a jump of $10 here. We even get a jump of $6 here. So overall, if you add up all those jumps, you're looking at getting yourself a nice $60 increase. So that's worthwhile if you're going to, if you have a choice. So that's how I would do that sort of question there. And that's one of the tricks here, is that you just need to learn what the new value of n is. Now, that's actually brought us to the end of the lesson. But Lena, if you have another question, I'm more than willing to go through it now because I've got some time before my next class. But if you want to head off and chill out, then that's okay as well. What would you like to do?
Sir, could you do 6 and 7?
Could I do 6 and 7? Was that you, Nia? Was that you? Who was that? That wasn't Lena, I don't think. Or was it? Oh, it was Arn. Hey, Arn. Yeah, sure. I'll have a look at question 6. Let's go have a look at question 6 and 7.
Oh, yes, sir. Thanks for the question, by the way.
Oh, that's fine.
Yeah.
Yeah, if you want to stick around, I'm going to do questions 6 and 7. If you don't, that's okay. Hopefully that helped. Did that help, Lena? Are you still here?
Yeah, because I just need to know what the semi and quarterly actually meant, like how to put that in the formula.
Okay, so you just need to know the main thing is n is the key here. N is the amount of times. Let's go look at question 6. All right, question 6, I'm going to start over here. Kim has $18,000 to invest in for 2 years. She has the following options. She has a term deposit which compounds annually. So that means n equals 1. Yep. And she's got 4.5%. Cool. Shares to pay a dividend of 11.12% per quarter. Nice. She's got a building society that's paying a return of 0.38% per month. And she's got a business venture with a guaranteed return of 0.1% daily. So yeah, I skipped this question because it is very similar to question 8, but question 8 was easier, but you can still do this one. So let's go have a look at what we've got to do is we've just got to go through each of these different possible methods and compare them. So first one, Kim. It
Percentage be the rate?
which one?
Would the percentage for each question be the rate?
Yes.
Okay. And then
So
the rate would be
when we
like,
talk about a dividend rate, so it's 1.12% per quarter. So it's 1.12% of what she's already earned. So the dividend is the only one that's a bit like, oh, the other ones are, yeah, that's how much she's getting paid for a rate. And she's getting paid that per month. The only thing I'm looking at, yeah, it doesn't say for any of these that this rate is per that area. So I'm going to assume that these rates are per annum, but and then they've just been calculated accordingly, because otherwise that would not make much sense. Because yeah, but that's how I would assume you would have to do this question. You still want me to do it?
yes.
Okay, so this is how I think you would do it. If I'm wrong, then I'm wrong. So we're going to do this. We're going to do for A, we're going to go A equals P1 plus R over 100, all risen to the power of NT. We know that P in this case is 18,000. She's investing 18,000. She's 1 plus the rate, which in this case is she's getting 4.5%, and she's getting that annually. So she's getting that N is 100, N is 1. So over 100, all risen to the power. She's investing in 2 years, so it's going to be a 2. That number at the end is going to be 18,000 times 1 plus 4.5 divided by 100, all risen to the power 2, so squared. So that gives us 19656. 19,656.45. Okay, for B, she's getting 1.12% per quarter. I'm going to do this one as the same way that I just done the previous one. I actually think it's a bit different. I actually think this is a bit different. Yeah. Okay, let me tell you why I think it's a bit different, and then I'm going to show you guys what I think we need to do. The reason I think this one's a bit different actually is that if you look at this number, right, 1.12% per quarter is actually relatively small, but it says it's per quarter. And then if you look at this one that's daily, that's really small as well, but that's per day. So I think these values are actually the interest per quarter. Yeah, this is the interest rate per quarter. Whereas the top one is the interest rate per year. So what I think would be worth doing is if we want to use our compound interest formula, we need to calculate the rate per annum. So let's do that first. So the rate per annum, is going to be the rate per a year. So if it's 1.12% per quarter, then that's going to be 1.12 times 4 for a year. So that's going to be 4.48. And I think this is how you're supposed to do this one. I'm just not 100% sure. So let's do this really quick. So how can I do this? A equals P, we'll just sub it in. We'll go 18,000 times 1 plus 4.48 over 100 times 4, because there are 4 quarters. So n equals 4 for this one. Risen to the power of 2 times 4. Now this number should be close to the other one. So let's go with that. 18,000 times 1 plus 4.48 divided by 100 divided by 400, all risen to the power of 8. Gives us 19.677.46. Now, just another quick reminder, why did we have to do this for? The main reason is because of this phrase here, per quarter. This is annually, this is per quarter. This one's per month, and this is the rate daily. So we can't actually use these as they are. We have to change them. If we don't actually have to change them. The reason that I'm changing them is because our interest formula is designed to work with rates per year. And if we don't have rates per year, it won't work. So let's do the rate per annum. For C, we go rate per annum. And the rate per annum for C looks like it's going to be 0.38 times 12. Why is it times 12? Because it's per month. So that's going to give us 0.38 times 12 gives us 4.56. Notice how all these numbers are very similar. 4.5. Yeah, notice these numbers are similar. Where is it? We've got 4.5, we've got 4.48, we've got 4.56. They're very similar numbers. So let's calculate this. A equals 18,000. We've got 1 plus 4.56 all divided by 100 times 12, all risen to the power of 12 times 3. Now, if you shove all that into your calculator all at once, 18,000 multiplied by...
Isn't it 2 years, not 3?
It is 2 years. Thank you. You just saved me because I just forgot. I was still stuck in that last question. Divided by 1,300, all risen to the power of 24. 19715. All right, we've got ourselves a new leader. 19715.38. Cool. Last one. D. Business venture with guaranteed return of 0.01% daily. I think this one could. Actually, don't think this one's going to win. We'll find out. So we're going to calculate the rate per year. So we're going to take this 0.01, we're going to multiply it by 365, which is going to be, I think, 3.65. Now that's not as large as the other ones, but even though it's not as large, we still may have a problem because it's daily. So let's calculate it. A equals, well, not a problem, but we may be able to make some money. But I actually think that C is going to be the winner. We'll find out. 3.65 divided by 100 times 365, all over 2 times 365. This comes out to be, let's do this, 3.65 all divided by 36500, all risen to the power of, open bracket, 365 times 2. syntax error. What did I do wrong here? Oh, I've got two division signs next to each other. 3.65 divided by 3. It's got a, what the? I've got 3 division signs next to each other. There we go. Let's see if this works. And I get 19,363. 19,363. 0.08. So the winner here is, it looks like our winner is this one here, because it's the largest number. So therefore, my advice for Kim should invest in the building society as it has the greatest return. Ignore my bad writing because I was doing it very quickly. Now I'm not gonna. I'm looking at my watch. I want to get ready for my next class. I'm not going to have time to probably finish question 7. What I can do though, and if you want, Lena also wants me to do question 7. I can do a quick little video of me doing question 7 later, and then maybe upload it to YouTube or something and send you a link. But that's the best I can do. But if there are any other questions, then I can do them as well. Just send me an email what you want me to do. So I'll do question 7 later. But unfortunately, yeah, as I said, this is a bit of a weird question. I would not normally, it's not a normal type of question, but as long as you understand that the reason we can't just use these R values is because they're not per year. This R in this formula is specifically designed per year. And the reason why we divide by n, the reason why we divide by 12 here is so we can split that into a year. If you actually ignored that, right? If you think about it, we're timesing by 12 and then we're dividing by 12. We're actually undoing the same step we just did. Same here is if I divide times by 4 and then I divide by 4, I'm actually undoing that step. But the reason I'm doing it like this is because I know that you guys know how to use this formula. So that's why I thought, you know what, I'm going to stick to that formula. All right, ladies and gents, you guys have an excellent day. If you need more help, let me know. If you need to come see me in my office, come let me know. Otherwise, good luck and I'll chat to you later.
Have a good day, sir.
Thank you very much.
Bye.
Bye.
See you.